Here we are. Let me start with the semester 1 exam review. I'm trying to highlight the important areas that you need to focus on so that you can do your test well. All right, so among the topics we have done so far, the first areas that you need to know is SI units, both base units and derived. Like for instance, what's the SI base unit of Newton? Newton is a derived unit, so what's the SI base unit of Newton? That will be kilogram meters per second square because it's mass times acceleration. So likewise we have other units, like for work it's going to be force times displacement, and that's force already, so you get kilogram meter square per second square. So this is the basic form of the SI units. Then you need to be aware of prefixes. So conversions using prefixes, something that you need to be confident about. Like for instance, meters, kilometers, megameters, gigameters, terameters. Backward it is decimeter, centimeter, millimeter, micrometer, nanometer, picometer, and so on. So if you know the conversions, so these are the prefixes. K means 10 power 3, mega is 10 power 6, giga is 10 power 9, tera is 10 power 12, and decimeter is 10 power minus 1, 10 power minus 2 for centimeter, and then 10 power minus 3, 10 power minus 6, 10 power minus 9, 10 power minus 12, and goes on. So these are the prefixes that you need to use in order to get to an answer. Okay, so if you're asked a conversion, how many decimeter will be there in a kilometer, so you need to look into this and this, so you can see how much is a jump taking place. From here to here it is a 10 power 4 jump. So from kilometer to decimeter is a 10 power 4 jump. So kilo to deci. Deci is smaller than kilo. So if you're jumping from here to here, the unit is going smaller, so the number has to go bigger by 10 power 4. So it depends from where you're going to where. Normally you need to convert it to the SI base unit of meter. So if you're given something in micrometers, you have to change it to meters. If you're given something in kilometers, you have to change it to meters before you use it in problems. And the other thing is sig figs. You must know clearly when you add and subtract what rule has to be followed. So when you add and subtract, you need to follow the rule, which is add them up and then round the answers to the least of the decimal places in the given numbers. But for multiplications and divisions, you have to add the numbers, multiply the numbers or divide the numbers, and express your final answer to the least number of sig figs. So pay attention to those kind of questions. And there are a couple of questions which are based on that. Moving on to the second areas, we went through all the equations of motion. So we saw equations of motion, where we saw all the equations. Vf is equal to vi plus at, which comes through the definition of acceleration. And then we have vf square is equal to vi square plus 2ax. And then we have x is equals to vit plus half at square. And then x is also equal to vf plus vi divided by 2, the whole thing times time. When do we use these equations? It depends on what is given to you. Over here, what is missing is displacement. So if displacement is not there, this will be a best equation to use. If time is not given, then we can use the second equation. If final velocity is not given to you, then use this equation. And this is a displacement. This one doesn't have acceleration, so we can use that equation. So how you use those equations is, it can be used horizontally as well as vertically. If it is a vertical motion like free fall, then you're going to use acceleration due to gravity. Say for example, if I'm throwing some object up and then it goes and comes back to me in 4 seconds, what speed was it thrown? So if this is the question, it comes back to my hands after 4 seconds, what speed was it thrown? So if you look at the data, initial velocity not known, acceleration is minus 9.81, and the time is given as 4 seconds altogether to start from here and reach here, and you can see the displacement is 0. So we have 3 things, and we can figure out the 4th one, which is VI. So what equation is connecting all this? You can see the final velocity is not given to you, so you can use this equation. So x is equals to VIT plus half AT square. 0 equal to VI times 4, which is 4VI. And then minus half of negative 9.8 is 4.905. And then t squared is 4 squared. So if you shuffle it up, and you can figure out the speed. Alright, so this is something, and as you can see here, when the object is moving up, the acceleration is still downward, and that's why it slows down, and at this point the acceleration is still negative 9.81, and here also everywhere it's going to be negative 9.81. From the time it leaves till the time it lands, it is under the control of acceleration due to gravity. So remember that part of it. If acceleration is not there, like in this equation, when acceleration is not there, the only equation you can use is x is equal to VIT. So if you know the speed and the time, you can just multiply it. Okay, but make sure you use the proper units for it. This displacement time graph is also sometimes called position time graphs. So displacement or position, they're basically the same thing. So on a displacement time graph, if a line is like this, it means it is at rest at the same displacement. And how do you know whether it's moving or not moving is by the slope. Slope is equal to velocity. So the slope of this is 0, so it is not moving. So it is not moving. And now when you go like this, it is uniform velocity. And if you do it like this, it is a higher uniform velocity. And this means it is a negative velocity, because slope is negative and slope represents velocity. That's a negative velocity. So depending upon the different situations, you must be able to tackle this. Displacement or time graph or position time graph. The slope is the velocity. If the graph is if the graph is a velocity time graph, this line represents constant velocity. This means constant acceleration. So if you're asked to find the acceleration at a certain spot, you can just find the slope of this line. And to find the slope of a line, you need the y and x, rise over run. So you take any portion of the graph and find out rise over run, and you'll get there. On the displacement time graph or position time graph, if you're supposed to find the slope at any point, do the same thing. You need to find out the rise over run somewhere. Okay. So if you have a graph going like this, if a graph is going like that, and then straight, and then steep down here, and straight, and then again like that and like that. So you can see that this is position time graph. So what is happening here is constant velocity. So slope of this line will get you the constant velocity, and this is not moving. This is negative velocity, and this is not moving, and that is positive velocity, but not as big as this. It's lesser because the slope is less. This is zero velocity again. Out of this velocity and this velocity, which one's magnitude is bigger? So which one is a higher speed compared to these two? This one, of course, because the slope is bigger. Even though it is negative, the slope is still big. So those are things you should have an idea of. Average speed and average velocity. Average speed is the total distance over total time. Average velocity is the total displacement over total time. So make sure you know how to work problems there. So suppose you're given speed and time, you can figure out the displacement. So if you're going on a journey, going forward and going backward, so if you're given the speed and the time, and given the speed and the time, then you can figure out the displacements, and then you can figure out the average speed by total distance over total time. For average displacement, it's going to be total displacement over total time. That's average velocity. Okay, extending these to projectile motion, it's going to be the main thing in a projectile motion is it can be a horizontal projection where anything is projected like that, or it can be an angular projection where the object is going to go like that and land. In either case, it's the same thing. So if you have a velocity v at an angle theta, the horizontal component is v cosine theta, and the vertical component is v sine theta. The horizontal component never changes. Even at the very top, it's still v cosine theta, and it goes on. Whereas the vertical component is definitely going to reduce, and finally over here it is 0. And then up here it's reversed, backward, downwards. So the vertical component changes because acceleration due to gravity is vertical. There is no acceleration horizontally, so v cosine theta stays all the way down there. Even in this case, when you're projecting something with a velocity v, that velocity will stay the same. The only thing is the vertical velocity, which is 0 here, becomes something, becomes more. So vertical velocity is going to increase. So if you're asked any question on projectile motion, you can go ahead with the table, putting down the horizontal and the vertical components of all these things. You have to basically split it into two problems. The only equation you can use on the horizontal side is x is equal to vt. That's the only equation you can use on the horizontal side. On the vertical side, you can list this, you can use all the equations of motion. So depending upon the problem, if the problem is asking, well, how high does it go, so you just have to do till here. And if the question is asking what is the range, then your range is going to be like this way. So you're going to take all that into account. Okay. So equations of motion, those are the topics that you should be aware of. I will be discussing about some specific questions, but let me go through the topics first. And then you have Newton's laws. Newton's laws 1, 2, and 3. The first law is the inertia law, which actually states that an object will stay in the same state of motion unless acted on by external unbalanced forces. So that is basically talking about inertia. So why an object prefers to stay in the same state of motion? That's because of inertia. So that's the inertia law. The second one is the acceleration law. So if an object is acted on by a net force, then the net force is equal to mass times acceleration. So that is our second law. And the third law says for every action there is an equal and opposite reaction. You must be able to identify which is the real pair for a certain force. Okay, so the pair for a certain force can be easily figured out by just renaming the force. So if I'm putting the pen on paper, the pen is pushing the paper downward. Where is a pair for that force? It's a paper pushing the pen upward. So pen on paper becomes paper on pen. And they'll be equal, they'll be always opposite to each other and having all those characteristics which we have discussed. So Newton's first law, second law, and third law, you should be able to use that in some situations. Like for example, if there's a problem like this with a pulley, and if there's a mass sitting here and the string goes like that and the string drops down, we have done something like that in class. So if you're asked what is the acceleration of the system, so you may have a friction here. Suppose you are asked what is the acceleration of the system. After you draw the diagram, the first thing you do is to draw the force diagram. So here is the force, weight of this one, mg, and then you have the tension acting upward, and the same tension comes here, and there's friction acting here. And after you've drawn the forces, then you should look at this and say, okay, which way is it supposed to be moving? This way. That means it's going to accelerate in that direction. It's going to accelerate in that direction. So once you decide it's going to accelerate that way, then we set up equations. mg is bigger than t. That's why it's accelerating downwards. So mg minus tension is equal to ma. And over here, we know that t should be bigger than f. So t minus f, the frictional force, is equal to ma. Now the masses can be different. This is m1 and this is m2. So that will be m2a and this is m1a. Okay. Once you set these up, you can add the two equations and all that and simplify and get the a. A stands for the acceleration of the system. So there are problems where you need to kind of think about putting all these forces and getting them done. And some problems are slightly lengthier, but there are so many other places where you can save time. Okay, so that is about Newton's laws. And then we talked about circular motion. So make sure you know the basic ideas of circular motion. When something moves round and round, there is a centripetal force required. There's a centripetal acceleration, therefore. And the centripetal acceleration is v square over r. You can also use it in other formats, but most famous usage is acceleration is v square over r. So that's the acceleration that is actually acting on something to make it go round and round. The centripetal acceleration is this one. Okay, and r stands for the radius of the turn taken, v stands for the speed, and a stands for the centripetal acceleration. So be familiar with the use of this equation. Work, energy, and then power. Work, energy, and power. Work is Fd cosine theta. So you can have negative work done, you can have positive work done, but you can also have some kind of fractional work done. So depending upon the angle, you can figure out whether it is negative work or positive work. Energy, you know, the energy, the kinetic energy is half mv square, and you must be familiar with how to use it. Potential, gravitational potential energy is mg delta h. And for problem solving purposes, you can always take a reference level as zero potential energy. And then we have elastic potential energy is half kx squared. So this is the elastic potential energy. So energy can be of any formats. There are many more formats, but at least these are the ones which you need to know for this semester. Power is the rate at which work is done, work done over time. And all these are measured in joules. Also this in joules. This is measured in watts. A watt is 1 joule per second. So power of a light bulb. So you should be familiar with that, with this wattage. Power is also energy over time. So make sure you have an idea of that. And in springs and stuff cases, you have to use half kx squared, where k is the force constant, and the unit of k is Newton per meter. The unit of k is Newton per meter. So if a spring stretches or compresses by x displacement x or extension x, then you can use half kx squared and find out how much is the elastic potential energy right there. Okay. If you have a force displacement graph, and if you're given a special graph for this, like force going like that and like that and like that, force displacement graph, the area of force displacement graph gives you work. The area of this graph. So if it's a trapezoid, you're going to use the trapezoid's area. Okay. So that is going to be work, because the area is FD. You just have to find the total work done by taking the area. And when we discussed about friction here, you saw there were two kinds of friction. Static friction is μs times normal force, and we have kinetic friction, if it's already moving, is μk times nr. nr is a normal force. μk is the coefficient of kinetic friction, and coefficient of kinetic friction. So friction force normally depends on these two factors. This is the nature of the substance, and that's normal force. That is what friction generally depends on. Now, fluid friction depends on area. Fluid friction depends on how fast we are going, and also fluid friction depends on the nature of the fluid itself. So understand the use of this equation. Okay. Now let me give you some sample problems that can be of importance as far as your test is concerned. Sample questions like, if a ball is dropped from that level to here, how fast should this be moving at the bottom here? We can do that by just using GPE equals to mgh at that point, and kinetic energy here is 0 because I just dropped the ball. Over here the GPE is 0 and kinetic energy is half mv squared. If you equate this with this, we end up getting the speed with which it's going to hit the ground, because you are dropping it from a definite height. So we know mgh, and you can easily figure out where it's going to land. All you do is just equate these two. Now, if resistance, air resistance is there, then they will tell you either the air resistance, or they'll tell you, so let's find out this. If the mass of the object is 100 grams, so it'll be like 0.1 times 9.81 times the height, suppose it's 10 meters. So, and the answer is going to be 9.81 joules. Suppose as the ball is coming down, if air resistance is doing work, and the work done by air resistance, if that is equal to a negative 40 joules, or negative 4 joules. If that's a negative 4 joules, work done by air resistance, then what happens is, this is the energy that was on the top. Where as this was coming down, it is doing this much work on it. So 9.81 over here, minus 4 on the way down, and that will be equal to the kinetic energy here. So the kinetic energy here is supposed to be equal to 9.81, which is on the top, minus 4. So it will be 5.81 joules. 5.81 joules is here in the form of not potential energy, but just kinetic energy. So equated to have m v squared. So you can figure out what speed it will come and land by just using this method. Okay, so you can just solve this one. So multiply through it by 2 and divide by 0.1. You'll get v squared, and don't forget to take the square root, and you should be able to get there. Okay. So you can see how friction is involved. So even on an inclined plane, the same story. On an inclined plane, friction is mu k times mg cosine theta, because there's a cosine theta component. That is friction. And the downward force, you can use the downward force mg sine theta to work the problem out, but as I said earlier, you can actually go by this, the mgh, and kinetic energy is nothing because it's just like started there, and potential energy is mgh, kinetic energy is hardly there, and when it comes here, the gpe becomes 0, and the ke will be something. So this thing has to move at a certain speed. Now this is without air resistance, without the air resistance. But if there is a resistance, then the frictional force is that. So how do you incorporate the frictional force here? The work done by frictional force, is the work done by frictional force is Fd, and this is the F. So mgh is on the top minus Fd, where F is all this, is equal to half mv squared. So even if mass is not given to you, the mass is there in each and every quantity. So you can knock it off. Okay, so mgh minus mu k mg cosine theta times d. D is this distance. Now if a certain distance is not given to you, you must be able to figure it out on the diagram. So just make sure that you do that right. Okay, and let me see. Okay, force times displacement is equal to the change in the kinetic energy. So a gun and a bullet, if you look at the gun and the bullet is actually being compressed, the energy is given in the form of a compressed spring, and after that the bullet is shot from there. So as the bullet is moving at displacement d, there is a force that is actually pushing it out. If you work in terms of kinetic energy, the kinetic energy is 0 here. The kinetic energy over here is half m the v squared. How fast is it moving at the end of this barrel? That is kinetic energy. So kinetic energy is 0 here, and kinetic energy is half mv squared. And how did it gain the kinetic energy? Work was done by the springs on the bullet, and the work done is Fd. So all you do is Fd is equal to this, and you should be able to figure out how far the bullet will be moving, or related questions. Okay. For all the questions, you should actually try and draw a small diagram, so you should be able to plan well. Stopping distance of a car. So a car moving at a certain speed v, if you apply a braking force F, it will stop at a distance d. This is very important for young drivers, basically. So when you're moving with a certain v speed, you apply the braking force. Suppose you even lock the wheels, it's going to drag you to a displacement d. So this is called the stopping distance. Now, what will happen if this velocity is doubled or tripled? So what will happen is the kinetic energy is going to become bigger. Now, what is the equation for this? It was moving with the kinetic energy, and here the kinetic energy is 0. So how do you plan to work this out? The force of friction is backward and it is displaced this way. So it's a negative work done. So the negative work done is equal to the final kinetic energy of 0 minus that. 0 is the final kinetic energy, and before the kinetic energy is half mv squared. And as you can see, the halves will cancel off and you can actually compare the two of them. So there is a certain displacement or stopping distance. What will happen? You can look at this equation and say, what will happen if the velocity is doubled? If the velocity is doubled, the half mv squared is going to become 4 times bigger, which means if you hit the brakes like that, your car will slide for a bigger distance this time, because you are moving faster and the speed comes as a factor of, as something being squared. So remember this part of it, and that's the reason why the distance is going to be quadrupled. So if the velocity is doubled, the distance is going to be quadrupled. For example, if you're driving a car at 30 miles per hour on a road, you have a certain stopping distance. You have a distance, let's say, of 50 meters. Oh, that's too much. Okay, let's say you have 20 meter stopping distance. Now, what will happen if the velocity is changed from 30 to 60? So you're doubling the speed. When you double the velocity, what will happen to the displacement? When you double the velocity, okay, yeah, so if you're going at 30 miles per hour and then you change it to 60 miles per hour, so when you go from 30 to 60, your velocity is getting doubled. So the velocity square is going to become 4 times bigger. And when the velocity square becomes 4 times bigger, the displacement or the stopping distance will become 4 times bigger. So instead of stopping at 20 meters, you end up stopping at 80 meters. So you can see how dangerous it is to drive at a higher speed, because your stopping distance itself is going to be higher. Yes, it's almost like I've covered almost all the points. I've got all the points. If your masses are given in improper units, you have to change it before using it. Any measurement, the SI units are meters, kilograms, and seconds. If it is not given in the proper units, you have to change it before applying it. Okay. All right, so this is pretty much what you need to be looking into in order to prepare. There are lots of numericals, so make a note card of all your equations, and you should know when you're going to use those equations, in what situation you're going to use those equations. And okay, so good luck with your semester exams, and you will be, there will be a tiny curve applied that will be decided after you finish the test. Okay, so all the best to you. Don't forget about the note card. Come with the note card prepared, and also go through some of these areas that I have talked about right now, and plan your problem solving by proper diagram, and find out which equation is going to be helpful. We did many questions in class about inclined plane, the sliding, the child sliding down, so how the energy is getting transferred and so on. So you have a lot of energy questions involved in this test. So, and equations of motion. Some questions are actually much easier than they appear. Okay, so just make sure that you are aware of everything, and good luck. Good luck with semester 1, and happy Christmas to all of you. All right.